Okay, we're live. All right, so I'm having them kind of do a couple things in the. Okay, got your graphing calculator out. Where's your graphing calculator? Oh, I'm sorry, I didn't see it. I actually didn't. I thought you didn't have it out yet. Okay, all right, should already have your limit statements. So take a look up here. And then we made a management decision as the notes look like this. I actually have a way of making those lines turn into straight, perfect lines and so on and so forth. But the big deal on this one is if you multiply this out, you should have got a 2x to the fourth, right? Isn't that the leading coefficient, correct? Make sure I'm not wrong. So therefore, this would end up and up, all right? So I should probably do have all those curves in there. I could make a sketch of this, but then I'm going to go synonymous with what the graphing calculator tells me. Where are the extrema? That's why everything else is blank. Everything else is calculator, because that's the only way you can find the high-low points. Wrong. You could find it through a calculus thing called finding derivatives, then input-output. That's something you'll do in calculus probably. So we are stuck with our calculator. So first things before I go to that though, 1/2 is a 0. So we are supposed to write that. So these I can do. Where are the zeros? Oh, real zeros. I already wrote them. Sorry. I forgot that I did that ahead of time. And I do want to, sorry, I almost didn't make a copy of this for my 5th hour. So I got to erase this. Yoink, 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 yoink. Copy. Sorry, I have to do this during the video. I just didn't prepare. I don't want to create a whole or have to erase later. Nobody cares what I'm doing there. All right, so 1/2, -3, and 5. Okay, so let's get those down here. 1/2, -3, and 5. It would be smart. This is actually setting up our window for the calculator as well. So we're going to go 5 to -5. 2, 3, 4. So one of the things I'll do in my calculator is set that window. All right, and then I got a 1/2, comma 0, and then I have -3, 0. Now the expectation of this is at this 0, I will have a bounce, but I'm going to see it when I look at the graphing calculator. What I want to do is like see what happens on how high this goes before it comes back down, and then set a scale for the y's. And then that's kind of the hard thing here. So that's not the hard thing, let's say the new thing. All right, my fat head's in the way again. I always have to do this. Okay, good. And I do want to see this. So I am again in the way. Maybe I'll just get rid of me today. I do like, knowing that we're live in class. But I'm going to leave this here. Okay, sometimes I remember I did this last week, I think, with you guys, and someone's like, wait a minute, where's the y = button? So they missed step 1, like where I was even at. So slow down. Hey, one more time, let's do this. Second, mem, just do it. Because sometimes you got some goofy things. If you lent your calculator to a friend, then they may put some illegal stuff in there and it won't be able to graph. Or I will tell you y = if your plots are on and you don't have any points, sometimes these are blackened, then I won't be able to graph anything. Y = 8x, which is just the line. I wish I didn't kill the, my face over here, but so we could see these things that I'm doing as we talk about it, but I guess you can see it on the screen. But anyway, y = enter quit. So here, second mem, get used to this, 7, 1, 2, which was a memory reset. As a matter of fact, when we have a graphing calculator test, I'm going to do this every time. Right? I don't know if you used your graphing calculator last year, your teacher probably should have done that as well. So one more time, second mem 7, which is reset, all RAM 1, hit the reset button 2, okay? And then we're back to this. Okay, enough of that. Bless you over there. 2x - 1, and then x + 3. Use the square button. If we're going to have a cubic coming up here, then it would be the caret button. But squaring, it squares and then it gets out of the exponent. When you hit the caret button, it stays up in the exponent. Then the next thing you type is still up in the exponent. You got to get out of it. It's just a thing that I've been telling you and the regulars as a quick clue. Okay, remember our window? Well, first of all, we're at zoom standard. Let's take a look at how high and low the loops go. All right. there's a very high top loop and then a very, very low bottom loop there. We definitely have an absolute minimum, right? Right? Okay, so, well, no one said anything. So -5 to 5. I want to try to match my graph here. Then this is a guess. That low went really low though. So I'm going to start with like -500. And then I'll just try positive 500 and then see what happens there. That's the highs and lows of the graph. Okay, probably a little too much. But see how that changed the picture? Made it more smooth and everything. Maybe not too bad though. So I guess I'll leave it. All right, so then I'll go over here and then I'll actually mark this. So I went up to 500 and -500, high, low. All right. And it worked and I ended up seeing everything. Okay. So then you could do like, I don't know, half of that's 250. You got to kind of 1, 2, 3, 4, 5. Try to like evenly space that out. -1, -2, -3, -4, -5. So go by hundreds on there. That's what we can, when we find these next things, we're going to be all right with what we grab here. Okay, so kind of important that we do see everything. And now I'm going to show you that thing that we should have already known. Well, first of all, we know this is a relative minimum. It's the bouncing 0. So that's a relative minimum where that graph hits that point. But I want to get that maximum. So second calc. All right, I hit that real quick. I'll hit it one more time. Second trace, which is the calc thing. And then what we want to find is a maximum. All right, at that position. I'm going to try to find that after the double 0. So I hit 4 for maximum, and then this is the weird thing. Okay, so get used to doing this. This is why we're playing along with this. You got to follow along and do the same thing. If you miss this one, follow along on this minimum, finding out what that coordinate is. But anyway, we got to get left of that hump. We got to get over to the other side. So it's on the other side of the high point. This is just how the calculator software works. Press enter, and then let's wait till we do the right bound, which they're asking for. We got to get over the hump to the other side. And then notice the arrows. Press enter. They're pointing at each other. The arrows are pointing at each other, and they will find the highest y value between those arrows. That's what we want. I don't know why, for some reason in the past, students couldn't get left bound on the left and right bound on the right. Their arrows were pointing away from each other, and it'd be an error. The calculator would shut down, like, what are you doing? Right? I haven't found problems with it lately. Maybe you guys are more technologically advanced with that phone in your face every day. Who knows what it is? But anyway, -0.83, comma 73.02. -0.83, comma 73.02. -0.83. -0.83, comma 73.02. And what is that? A min or a max? Min or a max? What is that? Max. What kind of max? Absolute or relative? Okay, so I'm kind of squeezing this in here. Let's put R max. So it's a relative max. And we're not going to use all that lingo because there's no space. The max is 73.02 at -0.83. And now for our sketch, here's -0.083, and then here is like 72, a little bit up there, right? Right. Okay. And then I just want to look at it one more time on my graphing calculator that it looks good. Come on, why is that not going? Yeah, so it kind of slides way out there and then comes out to here. So this is coming from here, bounces, and then hits this top point, and then we see the next thing that happens. So that's that top point right there. So now I can make a kind of sketch there since I did my scaling. So this is how you play around with your scale accordingly. And then we're going to get that minimum. So I'm going to go back up to the calculator and press the buttons like you would. Same thing, second trace, which is the calculate menu. Now it's a minimum 3. It does say minimum up in the up in the screen top left corner. You could press enter now because you are left of that minimum. But just wanted to make sure you understood that you want to kind of get close. That's good enough. Press enter. But now you really got to get to the right side of that. So you have to go all the way across. So even though you can't see me typing the buttons up here, you can hopefully hear me and then see the screen here where I'm getting left bound and right bound. And then press enter. Okay, and you get 3.46, negative 380.46. Oh boy, I'm going to have a hard time remembering that. So go ahead and write that down. 3.46. Come on, pen. 3.46. And then that's a relative or absolute? What is that? Relative or absolute? Absolute min. And then that was 3.46. What? Negative what? Help me. Negative what? Why is no one saying anything in this fourth hour? You're doing the same thing I am. Negative 380, right? Point what? 4 what? 7? 4.6. Are you sure you rounded right? I'm getting nothing from fourth hour. I'm alone. It's like I'm at home with my 2 teenage daughters. Shut up, Dad. Leave me alone. All right. Anyway, that's what we got there. So 3.46 and then 383. 3.86 and then right around 380. Stop it. Screen's moving around. Okay, so then I go through. None of these zeros have any multiplicities except for 1. So then that's a reasonable sketch there. Okay, so I actually found these, and then that allows me to find increase and decrease intervals. Okay, and that's really the key. Okay, so intervals of increase, we'll just put an I here and squeeze it in here. I don't think I'm going to be able to do all of this like for every single example because it does take time. I think the point's made. You got to get your maximums and mins, and then from there you can get intervals of increase and decrease. Actually, the first one is from negative 3 to that negative 0.83. So increase from negative 3 to negative 0.83, the x's, right? You always name the x's that have this happen. All right, and then, well, this minimum here, absolutely, that was at 3.46, right? So 3.46 to infinity. That's where it increases. Where it decreases is probably 2 intervals as well. Yep, we got negative infinity to negative 3. So negative infinity to negative 3. And then decreases from those 2 special max and mins that I found. So negative 0.83. Where did I lost myself? Negative 0.83 to 3.46 is where it decreases. So these 2 x's, those x's that I found when we were on the calculator there. Okay, so the whole idea is how to do that. I guess you could practice one more time on this. What I do have to do is show you zeros on the second one. So let's go ahead and type the second one in, and then we'll move on. But I will find all the things that you need to on the second one, but we got to start over, and we might need a brand new window. So clear. I'm going to move the calculator over. Oh, can I? This is getting, okay, let's see. Okay, I guess not. Crazy things happen on this computer. All right, I got to go back to the computer and shrink this down a little bit even more. Can I? Okay, there we go. At least I could see the x cubed. All right, so I cleared, and we're going to have to mess with our window. So I'll bore you with here we go, x caret 3. All right, that's what I mean. I use the caret button. I'm stuck in the exponent, so I get an arrow out of it. I don't like that feature. I wish it would go out immediately. X squared. Hope you're watching. This is really not hard, but it's brand new, so kind of got to show you the attributes. Common thing is people sometimes forget to put an X there, and then their graph doesn't look like mine. Don't make any mistakes in what you're putting in there. And then plus 2.49. Okay, I have no idea, so I'm going to zoom standard. Let's go do that together. That menu may not work for my last one. So I'm going to zoom standard, which is zoom 6, which I'll show you what that means. Actually, that's pretty dang good. What zoom 6 does is my window goes from 10 to negative 10 again. Okay, so it does incorporate everything I need. Well, actually, I got lucky. It gets me back to that negative 10 to 10, but I can tell I have everything I need. right? And that's the other thing about you can't be a robot. Boy, we're going to get later where you press graph and there's nothing. It's all gone. That's because zeros might be negative 12, 14 over here, and 20, right? That doesn't even incorporate those zeros. So you have to know how to work with your window in order to find these things. But going back to this, I kind of went ahead of myself there. We should know, I hit the minimize. Rough. Okay, got to go to this. We should know the expectation of the picture is this. When I hit graph, I got everything I need except that high point's a little cut off. So what could a window be? It looks like it crosses before negative 4. So I could go from negative 4 to 4 on the x-axis. And then maybe just a little bit higher on the y-axis. I can play around with that. I could leave the window. So what did I say? Negative 4 to 4 for the x's. Again, this is stuff that students sometimes have a hard time figuring out. That's why we're going over it. I could probably leave that at negative 10. I bet you maybe doubling this would do all right to the high point and see if I could see that or not. Okay, I do. I think I'm kind of okay with that. Or if I wanted to make my life easier, maybe I just go negative 20 to 20. It's up to you, whatever you mark. But when I look at my piece of paper, it's a pretty balanced y-axis. So we probably should just do that. Okay? Probably should just do that, and then we'll mark these things down. Okay, so you mark these. But here's the smart thing on zeros. Well, let's do max and min first. You go ahead and write these down. I wish I could write on the screen. I would, but then you wouldn't see it on the video. So I could kind of write these on the screen as we do them. But the first thing you're going to find is a maximum, and then I'll go up to the calculator and do it. Arrow left, 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 hitting the screen here like you would hit your own calculator. Watch this, watch this. Second arrow left, it skips. So if you do this real fast, it goes faster. I don't know if that's faster than clicking, but it does do like 5 at a time when you do second left. You are left. Second right. It skips a little bit more. If you can be real fast with your fingers, yeah, second move, it's pretty fast. Another little trick there. Then press enter. Go ahead and write that down. I'm not going to write that in the notes. Okay, so negative 2.28, comma 13.4, or you can go 3.7. I think 3.8. A common thing is to go to the 10th or 100th. I'm sorry, wrong. 100th or 1,000th is how they usually round on the, they usually say that on the AP exam. And then real quick, one more time, second calculate in case there's some stragglers, minimum. Okay, you can actually hit enter now, but now I'm using 2 fingers. Second right. And then it moves a little bit faster. I don't know if it really goes that much faster. Second right. Second right, just to make sure I'm over on the other side of that hump there. Okay, and then this is going to be a relative minimum. That is not the relative minimum. You have to hit enter on the guess. So it's enter a last time until it says the word minimum. Right, and then that's 0.63, comma 1.00. That's weird, to the 100th, or 1.003 to the 1000th. You be ready for anything on that. Now, here's the kicker. How do I find that 0? There is a 0 feature here, but it requires that left-bound, right-bound thing that students don't actually handle very well very often. So I always tell my students to find a 0 that I don't know because I don't see it in the equation. Put y2 equals 0. Watch the colors. This is great. Then you could find the what between these two graphs. What do you think? 3, 2, 1, go. Intersection. And watch how easy this is. It is second trace. It is not 0 now. It is intersect. You can't hit intersect if you don't have 2 equations. So be careful on that. All right, and you actually don't even need to go over here. But if there's more than 1 0, if you see 3 different x-intercepts, then you'd have to 3 times get close to where they intersect. And then I don't know why this exists. You just have to hit enter 3 times. I'm on the first curve. I'm now on the second curve. I don't have to, I'm just showing you. Now you have to do a guess, and then finally it says intersection. Okay, so that was 3 enters. It's the same thing if you did find 0 without this. Here, I'll show you what that is. you know, if I don't have this here, if I clear this, fine, I'll show you. Whoops. Second trace, 0. Then you have to do left bound, right bound. So I have to go all the way over here and go left of the 0. I don't know why students have a hard time with figuring out what's left of the 0. In this case, left of the 0 is below, in this case, when I press enter. And then I have to go right bound, which is right of the 0, which in this case above. Look at the arrows. The arrows are pointing at each other. It's looking for a 0 for y value in between those two arrows. Fine if you want to do that. I just think, you know, when I did the second, or sorry, no, let's do y equals. When I just did y equals 0, all I have to do is get close and press enter, 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 enter 3 times fast. 5? Well, actually, I know I don't even have to do that. I know there's only one intersection between these two graphs. Enter, enter, enter. And I already have the intersection. So it's a lot faster. Wouldn't anyone agree? Okay. So I'm assuming you're listening. And if you're not, good luck with life. All right. But anyway, I found all those things, and then we can find all the other stuff. Is that all right? Can I move on? I just don't feel like writing all this down, and you know, you could look at the key and go from there, because then we got this. I got some more calculator stuff to show you. Okay, so here we go again. Oh boy, I might get a sheet of paper for this one, so I don't have to keep trying to manipulate the calculator here. Go ahead and type this in, because I have some more stuff on the calculator I got to show you. It's really a calculator heavy day. That's the big day today. So clear. Maybe I'll leave y2 equals 0 in case they ask for 0. They won't on this one. It's not really pertaining to this. Negative 0.008. You don't need the 0 first. I did do the negative, though, making sure. Next, carrots, delicious, cubed. Right. And then say 0.2. Please do not make a mistake. X. And then I told you the squared button was great. If you can use it, you got a squared, use that instead of the caret. 2.418x. Don't forget any x's. Oh no, that's going to be a syntax error. Syntax error. Error. Sorry, I can't speak. Second insert plus. Okay, so I did accidentally hit a negative. It was an accident too, instead of the minus sign. So now I made a plus a negative. Those are two different things. It wouldn't have given me an error. It might have. No, I think it might have given me a syntax error. Or worse, it would have multiplied, and then that's not the same. And I would have had a crazy graph. Either way, that was bad. And that was another bad thing. I could have sworn I hit the decimal. Okay, 54 points. Okay, 586. All right. Now, so we get that in there. We'll manipulate the window in a second. We got to read the question, though. This is the temperature in degrees Fahrenheit of Kansas City, Missouri, right? X hours after midnight on March 23rd, 2019. Find the value of T of 2. By the way, what is T of 2? Explain what that means in the context of the question. What is 2? 2 hours. So what time in the morning are we talking about? 2 a.m. So we got to know what these numbers mean when we input them. Okay, but the next thing I got to do is maybe I'll hit zoom standard. I don't have a good feeling about it. By the way, the y-intercept is 50 something, 54. So it's gonna be 54 high. So I don't have a lot going on here. So window, man, what's a reasonable domain? Well, 0 is the starting point of this. So this really starts in real time. And then I might go 24, 48. You know, I might go 3-4 days out. In fact, the last question is, what would be a reasonable domain? Well, what happens in Kansas City in March, then April, then May? What goes on? It gets what? Warmer. Is this equation going to hold true in May? No. So what's a reasonable domain for this? Maybe a week? Wouldn't you agree? Before things start changing, especially at that point. So what's a week? That's 24 times 7. 168. I might just randomly pick this out. I'm going to go out a week on this. That's 7 times 24 hours. 7 days, 24 hours a day, just to see what's going on. All right, and then it looked like it was pretty high. Well, wait a minute. It's easy to think of the range. What do you think the temperatures are going to hover around? Look at the y-intercept. What's the temperature going to be around? 54. Like, so it could go down to maybe 35 and maybe up to 75. I don't know. So I'm going to say 30 degrees to 75 degrees, maybe. That's where it should hold in March. We'll see. We'll see if we cover everything here. Something's wrong there. All right, so I guess this is actually a little bit different. So I guess this range is pretty limited to just a couple hours. That's kind of strange how that happened. Hopefully I didn't type anything wrong in there. What did I type in wrong?
A plus sign after.
I did. What am I doing? Oh my goodness. What a buffoon. Or did he do it on purpose? No, he's a buffoon. Plus, I did it twice. What is my deal? Oh. Yeah, I definitely would have checked after that to see what happened. Okay, we got a little bit better there. Okay, and actually, when I look at this graph, maybe this graph is not valid very far out because this doesn't make sense at the end, right? Like plummeting and then going down to the negative degrees after a certain amount of time. So there must be some sort of limit on this based off of what I see here. So maybe answer that question a little bit better after the fact. Okay, but anyway, here's what I'm showing you. Second, calculate a value. Input, say it. Well, this does it for you. Boom. As a matter of fact, you will have graphing calculator questions where you have to do this. You can actually use the calculator to do the input outputting and get the answer. So what does this mean? At 2 a.m., the temperature would be 50.8 degrees Fahrenheit. Okay, and then you can write that down. You go ahead and write this down. I feel like I'm just here for like the calculator. You should be able to do this. Okay, and then let's go ahead and look at some other questions here. Close this for a second. I double hit something there. Okay, use the equation to predict the temperature at 5 p.m. You got to be careful. What does 5 p.m. mean? How many hours does that pass? That's 17. So that's just t of 17. Input, say it. Okay, so you hit second calculate and then value. Let's see if this makes sense, if this is maybe too far out in the situation. Yeah, maybe it does. Okay, so at 5 p.m., you're a little bit warmer part of the day. It feels like after this, though, when I look at this graph, it doesn't make any more sense. Like this is only through one day into the next, and then it kind of loses its value here. All right, so that's kind of what I see here in this picture, because after that, the temperature is not going to plummet below zero in the next couple days. Okay, so what is the average rate of change from 9 a.m. to noon? Input, say it. So this one I will kind of write out. Crinkle, crinkle. Okay, it's from 9 p.m. And March 19th. Okay, so 9 to noon. 9 is 9 comma, and noon is 12 comma. I have to input, output, find those two values, and then find the slope. So I'll do that real quick, and then kind of write the math for it. Second calculate. All right, value. It's harder with the mouse here. I'm not up on the board. 50.239. Fine, I'll write it all down. Really, this thing is not activating very much. And then it goes to this again. I'm just going to minimize this. Yep, that's true. Okay, I forgot it already. What was it? 50 what? Nobody's helping me fourth hour. They're all looking at me like I'm a fool. What? What? Then you trail out there. I'm an old man. I can't hear. What is it? 50 point what? He did it again. I'm just going to put 279. I think that's what I heard. Hi, caramba. What's with these kids? It's 239. Spitting all over the screen now because they can't talk. They can't throw their voices out there. I got to do everything around here. All right. Second, calculate. Okay, I think they get the point. Just want to make sure if I got some bum out there not following along. 53.074. 53.074. Why is this pen not closing this? 53.074. Was that right? Okay, so then you subtract this. You get it. It's amazing, though. I got some of my A-Bers that got all of these wrong on the last test. what are the average rate of change? And then that's all you do. And then press enter. Okay, I will tell you, listen, there's 4 written questions, but each written question on the AP exam has like 6 parts. I'm not lying. I'm not exaggerating. Of those 4, I feel like 3, at least out of the 4, one of the little parts was find the average rate of change between this and that, and it's always this. It's like over and over and over again all year long. All right, and then what's the problem with this? March 24th. This is the 23rd. So what is 9 on March 24th? What hour is that? That's 33. So you have to find 33, comma, and then this would be 34, 35, 36, comma. So that's all, and it's the same question. I don't know if it's still holding true. Like, I'm going to find the value of T35. Does this make sense? So I don't think this is going to make sense. Let's look at what T35 says. Right? And then we can kind of talk about what the domain is. There you go. That makes no sense whatsoever. Second calculate. That'd be like second calculate value 35. So the average rate of change between 33 and 36 doesn't really make sense. Probably, because that doesn't really make sense. I got negative 21. Is that what you said? Okay. I mean, it can get that, but not in March. That could possibly be a really horrendous temperature in January or February. I feel like February is always worse than January. It's never sunny here in our lovely town. So I don't know. If you looked at the things that seem reasonable, it probably only seems reasonable for one day, because then after that, the temperatures start taking off. So I'd say 24 hours, probably this is going to hold true. All right. Okay, so now we can just go to this one and then look at the end here. So a lot of calculator buttons. This one is not. Identify the domain of this function. Well, you got to be careful. When you have that dot there, that means it starts at -6, and it is a closed dot, so it's included. But with the arrow on the end here, that means it goes on forever to the right. So just knowing that, and then the same thing with the range, even though it doesn't state all local extreme end on a domain. The range, just for giggles, would be from, this doesn't go below -1, but -1 is that coordinate with -6, and that arrow goes up forever. So just so you know, you could read the range the same way you could read the domain from the picture. And then the relative extrema, this is an inflection point, not an extrema. So we're just going to kind of note that. This is the only ones that we have. It looks like at 0, 3.5, and then 4, -1/2. Wrong. And then -6, -1. -6, -1 is an absolute minimum. So just make a note for that. That's an absolute minimum. Those could be dots that end, and they're not necessarily the end of a curve or like a bowl part of the curve. They're just the last y coordinate and the lowest one. So again, the terminology, it is -1, add x equals -6, not a big deal. And then that's letter C. Sorry, I should have put that letter C and read my directions. Okay, then last but not least, see if you can make a sketch here. And then we'll see if you actually got this right. I'm going to freeze the screen, and then I'm going to talk through it with the computer and whoever's watching on the other end. Hopefully no one now. That'd be creepy. That means you're in my computer right here. So it's even with zeros at. Is there any such thing as -0, by the way? That's a dash. That's not -0, right? Ooh, multiplicity 2. That's rough. In 3, 1, 2, 3. Okay. And then such that, f of 1 is -16. I don't know. -5, -10, -15. Fumble. This is kind of easy. I should have said odd. That would have been better. Right? Odd would have been better. Right? How come no one's making a noise? There we go. This one's easy. Okay, 4th degree, even, zeros, and f of 1 equals negative 16. Write the equation. Wow, write an equation for it. That's tough. Use our calculator to identify extrema and label them on the graph. Interesting. So write an equation for this. This is good. So I'll write the equation after. Here's number one. Here's number one. You guys do your okay. Oh, sorry. I could have hit this there too. Boom. Right? Okay, and then what you should have had is this, right? Watch. Okay. Right? And then it said this was degree 2, so it's got to bounce. And then this goes through here. That's my reflected points. What does even mean? What kind of symmetry, by the way? What kind of symmetry? Y-axis symmetry. That's why I had to know that. That's why those green dots came into play. I flipped the green dots across the y-axis. So 1 comma negative 16 is a point, then negative 1 comma negative 16. Odd would have been better. I would love that because then the opposite of x would be the opposite of y, and that point would be up there. And then you'd have a bowl being concave down on the left side. All right, just so you know there how you do an odd function with that. With that being said, okay, and now here's how you write an equation. I'm just going to put that here. This is f of x equals. Well, you'd have x squared. You'd have x minus 3 from that original 0 given, but you also would have to have x plus 3 as a point, and then you'd put the letter a in front. Okay? All right? And then I would put one of these two coordinates in, 1 comma negative 16 or negative 1 comma 16. So 1 would go in for x, and then negative 16 would go in for y. All right, just like you did yesterday. Okay, so making sure that you do that. I want to make sure that would hold true for our extrema or our evenness of this function. Got to make sure I'm not missing something on that. So f of 1 equals 16. It's x squared, x minus 3x plus 3. I think it should work. All right, and then use your calculator to identify extrema. I'm going to shut this down after this because I'm going to assume that you know how to do that. Plugging those values, find in the a, then put the a back in, put it in the graphing calculator, manipulate the window to get to see those things. Okay, I'm going to shut the video down then at this point. Oh, that's not the right button. Okay, so it's everything we've done before.